Okay, so welcome back, and now we're going to do an example where both limits of integration are infinite. Okay, so in this example here, we show that we're going from negative infinity to positive infinity. And so what I want to do is I'm going to split this up into two improper integrals. Okay? And so I'm going to rewrite this as one integral going from negative infinity to 0 of x e to the x dx, plus another improper integral from 0 to positive infinity of x e to the x dx. And so what I'm going to do is I'm going to integrate both of these. I'm going to take care of both of these. And so the thing is, you have to remember is that if either one of these diverges, then the whole thing diverges and we're done. So if we do the first one and it diverges, we don't have to do the second one. So I'm going to do the first one and see what happens. Okay, so again, I'm going to rewrite this using limits, just like I did before. And so this equals the limit as t approaches negative infinity, and I'm going to say the integral from t to 0 of x e to the x dx. Now remember, we're going to have to integrate this using integration by parts. Okay, so don't forget integration by parts. So let's figure this out. So I'm going to let u, okay, u is going to be x, and dv is e to the x. And so that means du equals dx, and then v is going to equal what? V is going to equal e to the x. Okay? So now let's rewrite this. So this is going to equal the limit as t approaches negative infinity of what? Well, it's going to be uv, so it's going to be x e to the x minus the integral, again from t to 0 of u dv, or excuse me, v du, which is going to be this. So it's going to be just e to the x dx. And that's easy to integrate because the integral is just e to the x. So let's do it. So now this is going to be equal to the limit as t approaches negative infinity. And this is going to be x e to the x minus, now what do we get here? This is just going to be e to the x, right? And this is all evaluated from t to 0. Because again, what I didn't write down here is this is also evaluated t to 0. Okay, so now this brings me to this, and now what do I do with this? So now I'm going to use the fundamental theorem of calculus. I'm going to write the limit as t approaches negative infinity. And so what happens with this? This is going to be what? I'm going to evaluate it at 0. Well, at 0, this just becomes 0. And this becomes 1. So this is going to become negative 1 minus, and now I'm going to evaluate it at t. So this is going to be minus t e to the t minus e to the t. Now, what happens to this? Okay? Now, as t approaches negative infinity, well, what's happening to this thing? So again, let's rewrite this so we can see it better what's going on. So this is going to be limit as t approaches negative infinity. That's the key. It's going to negative infinity. And so this is going to be negative 1 minus t over e to the negative t, right? Minus, oh, sorry, this is going to be plus 1 over e to the negative t. Okay, so now why do I write it this way? Because as t goes to negative infinity, this is going to positive infinity, but it's in the numerator, or excuse me, denominator. So this is going off to positive infinity. Even though this is going off to positive infinity, this is growing much faster. And so this is going to 0, and this is going to 0, and guess what we end up with? We end up with negative 1. So it converges. So this part is good. Okay, now, what about the second part though? Okay, so now I'm not going to do the whole thing over again because we already know what happens with the integration by parts. So what I'm going to do is I'm going to say, okay, well, what if this goes to positive infinity? So everything's the same. We're still going to end up going to here, right? So now, the only thing different is it's going to positive infinity. Well, if this is negative 1, oh, hold on, got to switch these. Hold on. So if we start over, let's do this one. The only thing that's going to change is the limits of integration, right? And the fact that it's going to positive infinity. So this is going to go from 0 to t, and now t is going to positive infinity. So I'm doing the same thing, but all I'm going to do is I'm doing this, right? So this is going to be from 0 to positive infinity, and then this is going to be positive. So this is going to go 0 to positive infinity of this, and so the limit of this going to positive infinity, and so this is going to go from 0 to t. Oh, hold on, I did this. This should be t. Right, the limit, so this is t, and this is t, and this is going to be 0 to t. Okay, and then here I'm going positive, and I'm going from 0 to t. Here, the limit's going to go to positive infinity, and now this is where it changes. Okay, so now, here it's going to be t e to the t, oops, t to the t minus e to the t minus this is 0. Well, this is 1. This is 0, so I'm going to get minus a negative 1. So it becomes a plus 1. Now, but here's the thing. This is going to positive infinity. So that means this whole thing is going to infinity, even though this is, this can be rewritten. Let me rewrite this. So this can be rewritten as e to the t times t minus 1 plus 1. Well, what's happening to this thing? Again, this is the controlling part of it. And so this is going to infinity, this is going to infinity, infinity times infinity is still going to be infinity. Okay? So this whole thing is going to infinity. Oops, not 8. And we're done because now this diverges. And since this goes to infinity, right, so this goes to negative 1, This is going to positive infinity, so therefore the whole thing is divergent. The whole thing goes to positive infinity. And that's it. Take care.